Good morning, friends. Once again, so we were discussing this concept now. Types of failures in the arch. Types of failures in the arch. This is the part coming under stability of the arch. So we are discussing stability portion. So in that stability, we are discussing what failures. We are discussing the failures. What type of failures can you expect in the arch construction or arches? First is crushing of the masonry, sliding of the visor, rotation of some joint, uneven settlement. Try to understand this one. Crushing of the masonry. What is happening here? If some load is coming on the top, if some load is there, okay, if some load is there, can you see this diagram? Let me go to this point, okay, like this. Okay, arcade, no example for arcade. It is the this is we call it as arcade only. Okay, so to explain the masonry crushing, I am taking this one. Or shall we go to the previous one where we can go like this? This is a good diagram for explaining the masonry construction. Sorry, crushing of the masonry. If see this one, if the total load which is coming on this top, which is coming on the top is little bit larger than the strength of this arch, if it is more than the strength of this arch, what is happening? What is happening? These things will get crushed, no? These things will get crushed. If the mortar is weak, if the brick or whatever the units are there, no, what is the name of the units in this arch construction? Visors. If visors are there which are not strong, and if the mortar which is used here, mortar which is used in the construction is not strong, it is very weak, if this depth, if this depth is less, if this depth, or another word is depth or height, if this depth or height is little bit less or short, if sufficient thickness or sufficient depth is not provided, all the three cases, what are the three cases? Poor visors or weak visors, okay, poor mortar joint or weak mortar joint, very less depth, less depth or height, or thickness, thickness is in another direction, this is the thickness, okay, this is the thickness, this is the thickness, this is the height, this is the height, okay. Try to imagine the points, okay. In all these cases, it will get crushed. Crushed means what? Making into small pieces, okay. It will get crushed under the load. So this failure is called as masonry crushing. It is called as masonry crushing. So what is written there? We have seen the things, no? Okay, like this. Crushing of the masonry. Here, what is happening? If the compressive stress, or we call it as thrust, exceeds the safe crushing strength of materials, which we call it as visors or units or mortar, then we lead to crushing. What do you mean by this one? The external compressive stress is more than the safe crushing strength. Strength means what? One may be mortar, another may be unit. If this exterior load is more than the strength of this masonry, what is happening? Crushing will take place. Okay, I hope it is clear now. So to avoid this crushing, what should be the precaution? What should be the precaution? So materials should be strong, materials should have adequate strength, size of the visor should be proper, okay, to sustain the loads. If very small visors are there, then it will get crushed easily. If bigger visors means what? Depth is bigger, thickness is bigger. If both things are bigger or larger dimension, then it will give sufficient strength under the crushing. What are the points here to be noted? Materials should be strong, first. Visor should be of proper size and shape, second. Third, what we have seen, no, height should be more. For that reason, how they have written? Height of the arch should not be less than 1/12 of the L. should not be less than. That means what? It should be more. Should not be less means what? It should be more, no? So depth should always be more than 1/12 of the span. L stands for what? Span, no? So in the diagram where you can, how you can understand, so this depth is there, no? This depth should be more than 1/12 of this span, 1/12 of the this span. Okay, I hope it is clear now. H, this is the H, this is the L. So H should be always more than 1/12 of the L. 1/12 of the L. If these three conditions are met, then crushing is not going to take place. Crushing is not going to take place. Is it clear? The first point, how the crushing of masonry will occur. More load, less material strength, crushing will take place. Less strength, less mortar strength, and thickness is also less, crushing will take place. If you provide strong visors, strong mortar, greater depth or height, then you will not have crushing. You will not have crushing. It is safe under crushing. I hope it is clear now. Okay. So this is the point. Okay. So sometimes you get different heights in the visors to be more stable, to be more, to get the more stability, you get more changes in the dimensions of the wires. So height is less near the crown, more height near the skew back. Can you see the diagram here? Just we will understand how the things are there actually. Less height near the crown, more height near the abutment. I hope it is clear now. Less height at the middle portion of this visors, more height or bigger size near the abutment, near the abutments. So that is also one precaution you can take. Sir, just precautions. Sliding of the visors. Sliding of the visors, I will just tell what is that. I will just explain what is the sliding. Okay. I'll just. Sliding means when the load is acting like this. When the load is acting like this visor comes out from this arch and falls. This visor comes out and falls, or you can say this will go up, this will go down. Okay, like this will go up, this will go down. These are called as a sliding. These are called as a sliding. I hope you are understood now. If more load is acting, no more load is acting, then this one will may go up and another will may go down. What is happening here? Transverse shear is more. Now it is clear now. Okay, transverse shear acting upon the arch members is more, and its a strength, mortar joint strength, this mortar joint strength or frictional surface strength is less. So that time this sliding will takes place. This sliding will takes place. To control that one, what is the precaution? To control that one, what is the precaution? So here they have written, to prevent the sliding, greater height of visor should be used. That is one common. If more height of the stone is there, then you will get more frictional strength and bigger mortar joint. Simple. Okay, simple. And also this angle between the line of resistance and normal to any point should be less than angle of internal friction. So in the diagram I will try to mark. Okay, here it is, this is pure technical point which is not necessary for this concept. Okay, but still I will try to explain now. Okay, now here line of resistance, according to this line of resistance. Okay, so this is the resistance portion lining. Normal like this is the normal, like this is a normal. Okay, this angle should be less than its internal friction. Where is, what is that point? Where is that explanation? Angle of internal friction. What three components are there? One is line of resistance, and normal. So the angle between line of resistance and normal should be less than angle of internal friction. Okay, now here I can draw. This is the line of resistance. This is the point under consideration, and this is the normal here, normal. This angle should be less than angle of internal friction, So friction is there. So that angle I cannot draw here. Okay, it is a pure materialistic property. So you understand this angle between line of resistance and its normal should be less than angle of internal friction. Okay, so that time what will happen? Sliding will not takes place. Sliding will not takes place. Rotation of the joint. What do you mean by rotation? Just I will try to explain here. Rotation means like this. This will come outside, this will that side. Okay, not in the vertical direction, in the horizontal plane. Try to imagine, rotation means this will come outside, this will go that side. So rotation about the joint. So this stone is coming this side and another stone will go that side. Means what? It is splitting in its depth, sorry, its thickness. Its thickness is distorted there. Its thickness is distorted. Sliding means what? Depth is distorted. Depth is distorted. Thickness distortion means what? It is called as rotation. It's called as rotation. Like this, it is rotating, it is also rotating. This is also one type of failure. So to avoid this, again, you should have what? You should have bigger bigger joints will avoid what? Rotation. Okay, now another point, what is there? It can be prevented rotation can be prevented if the line of resistance is kept within intradose and extradose. Line of resistance is kept within intradose and extradose. In diagram where I can show, yes, here. This is the line of resistance. This is the line of resistance kept in extradose and intradose. Line of resistance kept in intradose and extradose. Just try to understand. Okay. Uneven settlement. Uneven settlement. What is this uneven settlement? You have seen in the module 2, no? Foundation failures. So here, to avoid this, abutment should be strong and arch should be symmetrical. Arch should be symmetrical. In diagram where I can show uneven settlement means what? In this diagram only I will show. Uneven settlement. What is happening? Here poor soil, here strong soil. So strong soil will not settle, weak soil will settle. Means what? This portion will try to go easily downward direction. So this is also one type of failure. To avoid this, what is the precaution? You should have strong abutments. You should have strong or larger abutments. That time you can avoid unequal settlement. Here also you can see, no, this is also abutment, this is also abutment. If it is very strong, then you can avoid what? Unequal settlement. I hope it is now clear. Okay, these are the stability portion, very important, stability portion. So now we will go to the next portion, that is classification. What is there in the classification? How you can do the classification? Depending upon the shape. Shape of what? Shape of the arch itself, not visors. Visor size is fixed. Okay. Another term, depending upon the number of centers, depending upon the workmanship and materials used, bricks, stones, cement. Workmanship, poor quality, medium quality, high quality. Okay, like that, if the quality and material quality and workmanship quality, we can have a different types of arches. We'll just go one by one. Very easy, depending upon the shape. Okay, what is this? flat arch. This is called as shape depending upon the shape, no, we are classifying. So I will go to this diagram first here. So here one side we can explain the text also, another side we can have the diagram also. Classification of the arch. What is happening here depending upon the shape? Okay, flat arch. It is called as a flat arch. Here it has an angle formed by skew back as 60° with horizontal. Okay, now go to this one diagram. Go to this diagram. Angle formed by skew back. Where is the skew back? This portion. This is the skew back. This is the skew back. Okay, this skew back with horizontal is generally 60°. So that is why we have written it here. 60°. Skew back with the horizontal is 60°. Okay, it is 60°. What is there next in the this one? Flat arch. Thus forming an what? Equilateral triangle with the intrados. With the intrados. Where is that? Yes, here. So what is happening here? It is an equilateral triangle with the intrados. With the equilateral triangle with the intrados. Flat arch. We are discussing what? Flat arch. What other point you can see here? Very important. The name itself tells flat. So that means what? Intrados, extrados are horizontal and flat. Is intrados, extrados. In the diagram, you can see this is extrados, this is intrados. Extrados, intrados are horizontal and kept straight. Are horizontal and kept straight. So that is why we call it as a flat arch. 3 points. Skew back with normal angle is 60. Intrados, extrados are horizontal, okay, are flat, okay. So now where it can be used. So this type of flat arches are used only for light loads, means what? For less span. If the span is less, very less, that means up to 1.5, means what? Less than 1.5 and light loads, you can go for these flat arch. Flat arch. I hope it is now clear. What is there? Angle is 60°. What angle? Skew back with the horizontal angle. Okay. And intrados, extrados are flat as well as horizontal. Okay. Intrados, extrados are horizontal and is used for light loads and smaller span. Smaller span. Okay. I hope it is clear. We are discussing what? Classification. Segmental means what? It is very common type. Segmental means very common type generally we use. Whatever the explanation we are doing now, so with respect to segmental only. Here the center of arch lies below the springing line below the springing line, and load is transferred to the abutment in inclined direction. In inclined direction. 2 points. So we can go to the diagram here. We can go to the diagram. Now, this is the typical segmental arch. This is the typical segmental arch. What is the first point there? What is the first point? Center lies below the springing line. Load is transferred in a inclined direction. Okay. Now, center. Let me point here. Okay. Imaginary point center here. This is the springing line. This is the springing line. What they are telling? Center is always lying below this springing line. Yes, absolutely correct. This is the two imaginary points. This is the springing line and this springing line, and when you compare this, the center or striking point, center point or striking point for this arch is lying below this, lying below springing line. Another point is what? Load transferred to the arch here from arch to the abutment is in inclined direction. Very simple. Okay. So here it is not a horizontal, no, it is inclined direction. So that is why load is also transferred in the inclined direction. I hope it is now clear.